Thank you very much for joining the RIST Applications webinar. My name is Ciro Noronha. I'm with Cobalt Digital. I'm also the president of the RIST Forum. And with us, we have David Griggs from AWS and Tim Baldwin from Zixi. Let's get started. Agenda for today is first an introduction to RIST. What RIST can do for me, who's involved in RIST, you'll find out all the players and a high-level technical overview. This is not a what's RIST webinar, is more of application. So that introduction will be brief. Then we'll see RIST in action, how the customers use RIST, why RIST is important to customers, and a few use cases will be discussed, the actual use cases. So let's start with what RIST can do for me. So what's the problem we're trying to solve here? I want to use the internet as a cost-effective means of transporting high-quality broadcast-grade video, because internet's there, I'm already paying for it. So it moves bits. So can I use that for broadcast? Now, there's many buts here. What are the challenges to that? Obviously, internet delivery to the internet is not guaranteed. The video may glitch. If I have multiple links, I want to be able to use any link or combination of links. I may have cellular, I may have whatever. I want to combine all these links and move my content. Yeah, that's doable, but there's many solutions that add a lot of latency. That's not useful for live cases if you have like 40 seconds of latency. Also, very important, I want my content to be protected so it doesn't get stolen. My content's valuable and needs to be protected in flight. The other aspect of this is bad people shouldn't be able to hijack my feed. You send a reporter to the field, reporter is going to transmit back to the station. What if it's not the reporter? So that needs to be taken care of. Also, my IT people are very busy. This needs to be easy and straightforward for them to set up. So those are the challenges in using the internet for transporting broadcast-grade video. They'll say, okay, fine. There's lots of people, including some in this call, have solutions like this. A number of solutions that have existed for a number of years. So why is RIST different? So RIST was designed as a joint effort between many of the leading companies that provide video delivery over the internet. And the idea really here was to make a common specification without compromising on the quality. So these companies, which actually compete in the marketplace, got together and freely shared their experience for this effort. And the technical group chose best of class technologies for every aspect of the protocol while following established standards, because we don't want to reinvent the wheel. So the final choice for that, final result for that is that you as the customer, the user, you have a choice of your best equipment for your specific needs. And you don't have to worry about, oh, this doesn't talk to that. You can use one vendor on one side, another vendor on the other side, and they will talk. You're not locked to a single vendor, single technology, and you don't need to compromise quality. You're not making compromises. You get that, and you get the best possible quality. So, okay, that sounds very good. So who's behind that? Who's making that happen? I have this nice slide here about the players. RIST is an effort that is in the context of the Video Services Forum, the VSF. Inside the VSF, there's the RIST activity group, which is composed, again, by the people who've been doing this for a while and also by users, right? Because we need to, the final thing is for the users. So this is the tech people. The tech people then produce the RIST specifications, which are published and freely available. Tim is going to talk about that later. And then there is the RIST Forum, which is the kind of the marketing education people. So marketing sometimes is not well seen, but it's the education people, the people who bring the message to the market. So I personally, I'm the president of the RIST Forum, but I'm also in the RIST activity group. I'm actually the guy who's the editor of the specifications. So we play both sides. And all the companies that are in the RIST activity group also participate in the RIST Forum. So it's a synergy there. So I'm going to give you an overview of RIST technology. We've had webinars in the past where we had deep dives on the technical aspects. That's not this. This is just to set the stage for the discussion later. So let's start with the timeline. RIST was created in February, the RIST activity group in February of 17 during the VTrans. Between February and April of 17, we didn't do anything. April of 17, we met at NAB and started the process. Took a year. In April 18, again at NAB, we had the RIST simple profile. That's when we sort of internally approved. And then in May of 18, we had a closed interop where the companies got together virtually, actually. There was no pandemic, it was all virtual. It was at Cisco in San Jose, California, but everybody transmitted from where they were, and we had this interop. We learned some things. We had the second draft in July of 18. In September of 18, we had a public interop at IBC. So we pushed it in the at YouTube. Everybody saw it live, and it's still there, recorded. And then in October of 18, what's called RIST Simple Profile was published. And that's about when the RIST Forum was started to bring the message to the market. Now we have products. April 19, again at NAB, many companies already had commercial products. We also had a big public interop at 19. Continue working. In September of 19, we had main profile. Another public interop was conducted. And then in about March of 2020, we published main profile. And commercial products are available, have been available ever since. You can find those in the RIST Forum website. So what's this business of profiles? Okay. RIST builds on top of profiles. We start with simple profile. Simple profile is concerned with getting the content there in a reliable manner. So ARQ is the basis. We have retransmission throttling, the link aggregation, which is very important, and redundant paths. That's all in simple profile. Now that we get it there in simple profile, we need to have it protected. That is main profile. So we created tunneling to make your IT people happy. We added encryption, authentication, and some other things for further optimization, which is high bitrate support, no packet suppression, that kind of stuff. I'm not going to get into those technical details. Outside of that is advanced profile, which is not out yet, although we are very close to having the first specification for advanced profile. There's some tests going on, but it's not publicly out yet. So the main thing we're going to do here is tunnel level enhancements, which gives you lossless compression, tunnel level ARQ, so you can use RIST for other protocols. You can RIST for other things that just go into a tunnel. And we're looking at things like receiver synchronization, where you have a whole bunch of decoders, and you want them to be frame synchronized. Call home, multi-session management, and adaptive bitrate, which is very important, because if the available bitrate drops, you got to drop as well. Yes, there's solutions in the market today, but this will be interoperable. So let's look at the technical base. What's the base features? The base standard in RIST is Rtp, the real-time protocol. It's been around for a while, which makes it compatible with non-RIST devices. This is the same Rtp that you all know and love, or maybe not, but so you all know that is compatible and works without the protection, but it's compatible. But what else we have? We have packet recovering using ARQ, and that got us all an Emmy award. not because of RIST, because of ARQ, but this can take you to 50% packet loss. 50% packet loss, the protocol is to call IT, have it fix it. But while they do that, you have RIST covering your back. Multi-link support, which allows you to do two things. One is bonding. If you have multiple links, you can spread the stream and then bond them together, combine them for your transmission. The other is seamless switching, which some of you who are familiar with standards is SMPTE 2022-7, which is you send multiple copies, and if a link goes down, you just use the other one and it doesn't glitch. So it's seamless switching. All right, tunneling support. So what's this business of tunneling you keep talking about? It's combining multiple streams into a single port. So it's simple for IT. Instead, so if you had 10 streams, IT would have to open 10 ports. No, only one. They'll love you for that because it's all less work for them. Only one port to open. And the connection can be started at either point. You have a sender, you have a receiver, multiple receivers, but you open it from the side that's most convenient for you. And the tunnel is bidirectional. The other thing that's very cool about having tunneling built into RIST is optional support for any type of out-of-band data. So once you have a RIST connection, you can have a technician ride that connection and talk to the equipment. So if you have like a van out, a reporter doing a interview or whatever, and there's an encoder that's sending back, that guy doesn't need to know anything about the encoder. If you need to adjust something, you ride the technician at the station can ride the connection back through RIST and adjust whatever it is that needs to be adjusted. Encryption authentication, that's the thing about the bad guys wanting to steal your content or wanting to send their stream instead of yours. We added top of the line AES encryption to RIST main profile. What it uses is something called DTLS. It's similar to the UDP version of TLS, which is the same stack that you are using today to connect to your bank. With encryption, the best thing you can do for yourself is not reinvent the wheel, is use something that's around, is being vetted, that the crypto experts are happy with, has been pounded on and found to be reliable. So that's the way we went with RIST, DTLS encryption. It's solid and is being vetted by industry experts. And we allow you to change the key size because in some places of the world there's restrictions. So that's built in. Also, if you say, oh, DTLS is too complicated, we have also a pre-shared key for one-to-many situations and also used in satellite scenarios, which is pre-shared key is just a fancy way to say there's a passphrase and you call them up and you say, hey guys, that's the passphrase for the stream, and they type it in. So that's a pre-shared key case. Now, authentication is the guaranteeing that you are who you think you say you are, or the person who is connecting to you is what they say they are. And authentication in RIST is certificate-based. I know many of you may not be crypto experts, but it's basically the same thing that guarantees that when you open your web browser and you connect to your bank, that thing over there that says your bank, it's your bank, is authenticated to say, yes, it's your bank. It's certificate-based, it's very reliable, and unlike the bank authentication, you can authenticate both sides. That's available too in the technology, but when you're connecting to your bank, you're just authenticating the other side, but you can authenticate both sides. And we have a simpler password-based authentication as well. Okay, fine, I want to buy that. I hope that's what you guys thinking, right? I want to buy that stuff. So it's RIST products. You can find the following from multiple vendors. Yeah, we all, many of us compete in the marketplace, but we got together here to make this happen. But you can find encoders with built-in RIST support, and all of these multiple vendors, not just one. You can find encoders with built-in RIST support. You can find decoders with built-in RIST support. You can find RIST gateways, which convert between RIST and other products. Many vendors for that too. You can find system integrators today with RIST experience, someone who can roll in and set it up for you. And you can find RIST services in the cloud, as well as open source RIST, which will be talked about later in this presentation. So now that I kind of set the stage, I'm setting the stage for the big guys to come and talk to you about RIST in action. So take it away.
Thanks, Zero. Thanks. Hello, everybody. Thanks again for making some time this morning for us to, we're going to take a little bit of a trip through some different reference deployments that can benefit from all of the advantages that Zero has been talking about with the RIST protocol. So Tim and I are going to take you through that. This slide here just shows you kind of the how broad the reach is already, though, in terms of looking at the members of this forum, who many of which have RIST products already. It's really a very vibrant and healthy ecosystem. And as we continue to add more features into the RIST protocol itself, of course, this will only get bigger. In fact, I'm pretty sure this is not an exhaustive list. I'm pretty sure there are members on here that we couldn't fit on. So that's always a good problem to have when you run out of room on a slide. Yep. Okay, so should we go through the let's go through the different use cases. Yeah. So I think one of the things we want to talk about first of all is how do customers use RIST? What is the real reason that we would want this kind of capability that we've been talking about so far? And the reason, and actually the answer is very broad, right? There's a number of different applications and deployments that use RIST that could benefit from the reliability and interoperability that are so inherent in that protocol. Anything that uses the internet is the Wild West when it comes to connectivity, and anyone that's tried to send RTP FEC over a long internet connection will know intimately how difficult that is for live video applications. So having that interoperability, but also having that rock solid ARQ based foundation in RIST is just a great, is really well suited for internet applications. Of course, that also includes applications that might span both the internet and public cloud infrastructure. So hybrid workflows where you need to contribute, distribute. In fact, as I say here in the last bullet point, pretty much all of the above, right? This is really a very, very versatile protocol that that can be used in a number of different live video applications. So, we've talked a little bit about satellite briefly earlier on in the presentation. Clearly, when we think about content distribution today, particularly of live content, you don't get too far into a conversation before satellite is mentioned, because it's a dominant technology. It's been around for a very long time, and broadcasters, I think correctly, trust it. But there are some challenges. And one of the, I think that certainly here, what we're learning a lot about is when you compare terrestrial IP technology with satellite, there's definitely some stark differences that I think are more in favor of these newer ARQ-based RIST-like protocols. And particularly, I think commercially, there's a challenge with satellite. This is expensive commodity hardware that somebody's paid a lot of money to put up in space. And so therefore, necessarily, they're looking for a return on that investment. And that typically results in long-term, either very expensive occasional use business models or very long-term commitments on the part of broadcasters. And it's generally, you're talking about multiple years of commitment, and it's very much a use it or lose it model. If you're not actively using the transponder that you're paying for, you're paying for it anyway. Mm-hmm. And I think this is, and Tim, I'm sure you come across this a lot. This is a big part of where Zigzee operates too, is that IP is just generally a much more agile and cost-friendly way to move content around.
Absolutely, and I think one thing that we talk to people about now, or we hear people talking about, is being able to do things like spin up channels really quickly to just try out a concept. So maybe you want to spin up a new channel and run it for a month and see how it works. So things like that just really are not practical with the traditional satellite contracts, but with terrestrial IP, it's easy to do. You can spin things up and down very, very easily.
Yeah, if you've forgotten to book your satellite access for a key event, you're in trouble, right? But with IP, you can generally recover quite quickly. I think the other thing that's really pertinent about satellite, and this is very much more a US-centric thing, is as part of our rollout of 5G, we needed to reallocate a large part of the C-band spectrum. I believe, I think it's almost half, or maybe more than half, to the telco industry, so that there's spectrum available for 5G rollout. That's effectively halved the amount of bandwidth available in C-band infrastructure. And so people will say, well, KU, surely that's the solution there. Well, not really. That requires a complete retooling of the teleports. You know, it's a different dish, for example. And also KU, because it's a much higher frequency spectrum, you tend to succumb more to things like rain interference and stuff like that for cloud cover. So not a great option. And frankly, why would you retool around a whole bunch of new satellite technology when you've got so many of the advantages of going to IP? We'll go to the next slide. Thanks, Sarah. So at this point, we're gonna roll through some really simple, well, progressively more complex, I think, different use cases of RIST. So these are use cases that I've come across working now with Media Connect for the last few years. So some of these, when we talked about this, Tim came to the table with, and we said, well, these are really good use cases that we've seen in the field that make use of RIST. So whilst there's no end customer names on any of these, they generally are workflows that we've seen in action at some point or another. This is really just talking about the interoperability. Like, this is such a cornerstone of RIST, is that when you're building out broadcast infrastructure, whether that's for contribution workflows or whether it's from more broad scale distribution workflows, this is rarely a single vendor idea, right? You're building out infrastructure there, and frankly, you want the choice as a customer to be able to pick the right tool for the right job, and interoperability shouldn't be a major consideration, right? That should be a given. Just like SDI on-prem has delivered that for years in the baseband part of our business, RIST needs to also provide that interoperability. And so that's such a cornerstone of the product that I just wanted to make sure right out of the gate that we highlighted that. And so here we're just showing a really simple contribution into public cloud, into a playout engine, and then being redelivered back to on-prem. So super simple, but just again, multiple vendors in play there.
Yeah, I think that's the key here is, any of these products shown could be replaced by, one of 10 other products for, that portion of the workflow.
Exactly.
So that's the interoperability that RIST is providing.
Right, and that's the way it should be, right? Customers need to choose the right tool for the job, not the right tool because it happens to work with this other solution, which I think is so much the problem, often the problem. Okay, next slide. So this is a really interesting one. Primary distribution is something that IP is really starting to see some inroads on. Now, it's typically been in the domain of satellite, just because of typically the number of endpoints that needed to be hit. But now, as we've started to develop these more sophisticated IP-based interoperable protocols that can provide similar resiliency, if not better, than satellite, we're starting to see more and more large, 3-core letter broadcasters get very interested in these types of distribution workflows. So here we're showing some play out on-prem. We're using a broadcaster to get that into Media Connect. Media Connect is using, and this is very simplified, obviously, this is heavily simplified, is then pushing that content out to 270 different DMAs, all using terrestrial. So this is really talking about the key value here. If you're a broadcaster that's using RIST for this type of workflow, it's about the reliability. It's about being able to get, obviously latency is important, but the key driver here is my content has to arrive at those affiliated or owned and operated stations across a large number of DMAs. I mean, typically we see most stations are talking in the US at least, to at least 270. And again, not all of those stations are owned by the network. And so the choice of hardware there might be different. And so the interoperability piece here, and we're kind of showing that with different types of receiving devices here, is super important as well.
Yep. I think another point to make here is, what we're saying here is primary distribution workflows, not secondary. So if I go back a couple years on the Zixi side, where, what we saw a few years ago was satellite might have been your primary distribution and IP terrestrial would have been secondary. But where we are today in 2021, it actually is primary distribution workflows using workflows very similar to what's shown here.
Yeah, exactly. And so a subtle nuance on the previous slide, but I think an important one is no, sorry, we can go forward. I was making a connection between the two. Is that once a station has received content from a network, their affiliated network, there's a complex process that takes place there where we take the content coming in, the so-called national feed. And again, I'm talking very much about a US-centric model here, but this model applies internationally as well. And that station needs to do some regionalization, whether that's localized ad insertion, potentially regionalized programming. But the point is, it's a very much a new form of the content is created there inside the affiliate station. Now, if you're having to be watching television though through your cable provider and not over the air, you want to make sure that when you're in Portland, Oregon, you're getting the local version of that particular content and not the one from New York. So there needs to be this recontribution of content from the regionalized stations, the affiliated stations, back to these super aggregators, these cable operators, so that they can then insert the relevant local station into their end viewers package. And that aggregator contribution is absolutely perfectly set up and a great use case for technology like RIST. It's agile, it's low latency, and of course, again, it's that coming back to that high quality aspect of it.
I think the same, on the MVPD side, it's those cable operators, but also your OTT operators like a Sling or Fubo that have live content. They need to have the correct live regional content for where you're located.
Yeah, that's a really good point you bring up, Tim, in that it's not just one or two aggregators or MVPDs. Now, the explosion of digital MVPDs is impressive, and so this is now a very complex onward distribution of content to these different aggregators. And so this is not just a many to one model; it's a many to many model now, which is again really interesting. And again, a really great use case for a technology that has the agility and of course reliability of RIST. Okay, next slide. So this is an interesting one because we've been talking a lot about 24/7, so-called sort of traditional broadcast television. But one really important aspect of IP delivery of content is in live event content syndication. And this is an area that I've been working on a lot with some of our customers around the complex nature of that content syndication. It's not a simple exercise. If you're running a multi-day sporting event, not all of your rights holders have access to 24, all 3 days, 24/7, or say 24 hours a day of that event. Often it's time sliced and access is given to rights holders on a very complex schedule. And so having the agility of IP, particularly to not send the bytes when rights holders don't actually or shouldn't have access to the content, not relying so heavily on encryption keys and temporary revocation of keys, but just actually stop sending the bytes when we don't need them is a really, I think, interesting and productive way to think about complex syndication of premium sports rights. And technologies like RIST, again, with that obviously that high quality bar, but also this agility of IP in general, I think make that possible in new ways that haven't been possible over satellite, for example, in the past. Excellent. Okay, next slide. So now we get into new broadcast. And again, you might think, well, isn't that all HLS and isn't that all, CDN delivery? How's RIST really help with a workflow like that? Well, any live event or channel all starts with a rock solid contribution, rubbish in, rubbish out, right? If you haven't got a really good solid contribution story for your OTT workflows, then you're not going to have good results downstream for your end viewers. And it's also, I think, worth mentioning that OTT in our industry has been thought of for so long as a kind of a bolt-on part of our broadcast strategy. And now we're seeing, and we have been seeing for many years really, is that broadcasters are looking at this in a more converged way. And so therefore having the agility of IP and RIST to be able to do essentially in a single head end, that kind of fan out, or that rather forking of content into your OTT delivery pipeline, but also into your primary screen, TS based, whether it's stat maxed or whatever delivery, that's a really powerful concept. And again, that comes back to the agility of IP and of course protocols like RIST.
Yeah, I think the contribution side of this diagram is even, it's fairly simplified. What you're actually going to be doing there is contributing into an editing workflow somewhere. It could be an on-prem workflow, or it could be a cloud-based workflow. So you might use RIST to get all your feeds up into a cloud-based editing workflow, and then maybe in a multi-cloud scenario, you might need to use RIST again to get the final program over to to where you're going to be doing the packaging and transcoding. So yes, there's definitely some more complexity on the contribution side than what we show here, but at the end of the day, you need to get your final program feed into an OTT workflow.
Exactly, yeah. And then on the next slide, because there was a lot of AWS on that previous one, I wanted to show that this is the beauty of RIST, right? It isn't a cloud technology. It isn't just an on-prem technology. It is a true IP technology which allows you to build workflows that span on-prem, cloud, multi-cloud, private cloud infrastructure. And I think this comes back to Cyril's point earlier. This is based on RTP. This isn't something new that we've created at that very basic level. It's based on a long-established real-time, effectively UDP data transfer. So with that comes the advantage of being compatible in lots of different environments and lots of environments at the same time. And so when you're building out your infrastructure on-prem, in the cloud, or across both, the RIST technology can be used to provide that interoperability and connectivity in a reliable way. Okay, so what are some important considerations when for a broadcaster today, and why is RIST so important? Well, if you think about our business, and I have this conversation a lot in my day job, data transfer is the product, right? It's what we do in live television. And so you need a rock solid connectivity technology. It's foundational really to our business. Next bullet. When we build out broadcast infrastructure, if you walk into any broadcast infrastructure building today, you're not going to see one vendor ubiquitously deployed. Like, it's not, there's going to be equipment from multiple different vendors, and that's good and that's healthy, right? I think that's actually a really good thing. But we need in order to do that, we need to make sure our customers aren't thinking about data plane connectivity and interoperability when they're choosing the right tool for the job. And so this interoperability foundation of RIST, principle of RIST, is just so important to broadcasters. So then they're not having to, that's not something they should have to worry about, right? Is interoperability. They should be thinking about, what's the application? Does it meet my needs? And yes, of course, these two things talk to each other. We've enjoyed that with technologies like 2110 and SDI on-prem. So why not in cloud environments and in more virtualized environments have that same, or maybe WAN applications have that same level of assurance that and RIST really does bring that. Next point. And then this is the versatility thing, right? We talked a little bit about this, content delivery used to be very simple. You used to have a RF tower transmission, and people had television set with rabbit ears on the top, and of course that's not the case anymore. We're now in a world where we have smart connected TVs, we have laptops, iPhones and tablets and all sorts of devices that are capable of receiving content and frankly are used. And so we need a technology that has the versatility to be able to supply all of those, or to work with all of those supply chains and that heterogeneous form of content delivery. And coming from that, and because of the points above this, RIST really does have that, and it provides our customers and our community with the right tools to make sure that they can put all this together. And so yes, agility, agility, agility. That's the key here. And a combination of IP and RIST really does deliver there.
Okay, let's talk about what's next. What's next for you in your journey with RIST? There are two ways you can get into into the RIST world. The first way is you can download specification and implement it yourself. As Cyril mentioned earlier, there's both the simple profile and main profile are specifications are out and certified, so to speak, by the group. And then the advanced profile is in the works right now, and it's coming soon. Over to the right, you'll see the homepage for the RIST group that you can go there and get the links, right off that page as well. So method one, implement it yourself. Method two is integrate an open source library that already has RIST in it. This is called librist. You see to the right there the link on videoland.org where you can grab this library. So if we go to the next slide, we can talk a little bit more about the open source. So librist, the open source library, is you can integrate it itself. It's also in GStreamer and UPipe, so you can integrate those products into your code base. And it's coming soon in the FFmpeg code base as well. So those are all ways that you can add RIST input and output support to your own products. And then from a kind of testing standpoint, there are RIST plugins available in Wireshark and also support in VLC so that you can easily watch a RIST stream that you're sending. And then of course once you're working with RIST and participating with the group, there are interop sessions with all the various vendors that you can participate in as well on the testing side. So you're not alone. I mean, on the Zixi side, we've done interops with most of the other vendors that are engaged in RIST, and so you're if one of the big points of RIST is interoperability. So once you get into working with RIST, whether you develop your own or you use the open source option, there's a group of vendors out there that will do interop testing with you to make sure that all the streams are working, all the products are working properly together. Okay, next slide. So what if I need help with RIST? So there's a Slack group, the Video Dev Slack group has a RIST channel. So that's a really good, real-time and active community that you can work with. And then, and lots of, of all the, many of the organizations that are implementing RIST have their engineers, on those, on that channel, having discussions and answering questions. So that's probably the easiest way. And then of course, going back to the RIST homepage that we showed earlier to, get a feel for the whole program. Okay, next slide. And then if you have questions, you can always send, other questions to info@rist.tv.
Okay, thank you, Tim. And we have two questions here. The first question is a simple one. What's an MVPD? So either one of you want to talk about that?
What does that acronym stand for?
Multi-video
Just describe what it is.
So what they are essentially the super aggregators. So you can think of large cable networks like Comcast, for example. Hulu would be a digital MVPD. Essentially, they are ways they provide a way for their customers to view multiple channels historically of content in a package. So when you sign up for your cable package, you're getting content from multiple different content owners that are aggregated into a package, and that's what an MVPD does. It provides those services. So traditionally cable operators, but now of course we're starting to see a lot of internet-based MVPDs, and we often call those digital MVPDs. So it's like the Prime Videos, the Hulus of the world as well.
Yep.
All right, thank you. Next question is a very long one. Is an interesting one.
Oh boy.
I'm going to read the whole thing, and I'm going to take some of it but not all. Okay. Would you mind compiling contrasting RIST with the many other low latency streaming standards? And he says SYE, AWS Acquisition, SRT, Quick, RIST, Zixi, SST, Netcode.io, Rtmp, WebRTC, Salsify, and low latency CMAF. So I'm going to take some of these.
And I have some color to add as well.
Yeah, I'll take some. Let me start. I'll take some, and then I'll turn it over for you. So let's start with SRT. SRT is something that's, we actually have slides about RIST over SRT. We didn't show. SRT is something based on an old protocol called UDT, which was basically a file transfer protocol. So just a sec.
Click on the answer tab.
Yeah. Answered. Yeah, sorry, it went away. So SRT is basically based on a file transfer protocol. It has several very strong limitations in terms of, it basically tops out at 10-12% packet loss. RIST can take you to 50%. It currently doesn't support multi-link, although they are adding it, because it currently doesn't support multicast. There's only one implementation of it, and it's equivalent to the RIST PSK. So it's got encryption, but not authentication. So RIST is a much better protocol. Rtmp, let me talk about Rtmp. Rtmp is TCP based. It's a very old protocol. It's a protocol that's married inside where to the flash container. So today it doesn't even support HEVC because nobody's taking care of it, and there's not a code for HEVC. Doesn't support MPEG-1 layer 2, doesn't support multi-audio. It is basically an obsolete protocol, and since it's over TCP, it has all the limitations of TCP. Once you have a few percent packet loss in the link, TCP just shuts down. Things like low latency CMAF, what they think about low latency is like a second, half a second. I mean, this is like the upper bound for RIST. You can, so it's for a different thing. RIST is lower latency than that.
So I just add some color on that. The other thing about low latency CMAF is traditionally it's a B2C delivery mechanism designed for over-the-top consumption. I have started to see some application of CMAF for distribution workflows that largely seems to be driven by cost versus and is more a comment on public cloud pricing than it is I think really any technical advantage there. So the other thing I point out about CMAF is that it's more of a B2C technology.
Yes. Jim, you want to add something?
Yeah, so maybe I can talk a little bit about RIST and Zixi. So you mentioned already the SRT is based on UDT. Both RIST and Zixi protocols are based on RTP, which we discussed earlier on the RIST side. And then and RIST and Zixi both have an ARQ capability. Zixi adds an FEC. WebRTC, which is quite popular now, or becoming quite popular, and actually just became a standard. It is based on UDP, and there's no protection. There's no ARQ. There's no FEC. So WebRTC can be super low latency, like anything that would be UDP only. But if you have any packet loss, you will have your video will break up. So there are uses for WebRTC when you need super low latency and the quality of the video does not have to be pristine. But it's kind of in a it's in a different it's a different use case.
I suspect that everyone that's watching us now is probably watching us over WebRTC because it's very popular in these videos. I don't know that the Zoom is that, but right. Typically it's popular in these web conferencing applications where there's a full duplex aspect conversation, and therefore you don't want like 2 seconds of delay. It's a nightmare, right? So and
the thing is, I mean, the laws of physics apply. So WebRTC, because it's UDP only, it can be super low latency, but you don't have protection. on the other end of the latency spectrum would be low latency CMAF, which will be a couple seconds. So there you're using, so it's TCP based. So if you have packet loss, you're going to have trouble. But you also have some amount of buffering there to help you out. RIST and ZXI and SRT live in between those two extremes, if you will, in that RIST and ZXI and SRT are all using an ARQ type technology, which gives you protection, but can't be quite as low latency as WebRTC, which is just UDP only with no protection.
Yeah, the only thing I'd add as well, I think it's just to your point, Tim, is that looking at the list of protocols that Robert's put up here, definitely the three closest together would be SRT, RIST, and ZXI, which are really about that TS broadcast B2B content delivery, mezzanine quality encoded content. The rest of these, not exclusively, but tend to get used for more lower bit rate, B2C, social media contribution type workflows, which are definitely a different use case. And I think what we're saying here with RIST is we're making the claim that taking a specification that we can all agree on for that interoperability is giving our customers the ability to have more freedom of choice when it comes to the tools and applications they purchase for these workflows.
Yep.
All right, thank you. So next question, which I'll take myself. Should customers join the RIST forum, or is this only for product manufacturers? How does one get more involved? Yes, absolutely. Customers should join the RIST forum, because you can guide, at least you can say, one customer once said, in fact, the AG chairman, he said, yeah, my contribution sometimes is to say, if you do this, I'm not going to buy it. That's valuable. That's useful. So yes, absolutely. Get involved, join the RIST forum. And if you want to direct or have influence in the standards, you join the video services forum, and then you join the RIST AG. Okay. All right. Does LibRIST support CMake build system? If not, will in the future. It's currently using Ninja. I'm not sure about CMAF. CMake. We'll get you in touch with the author of that. All right. Next question. RIST reportedly suitable for cloud environments. Is RIST compatible with containerized deployments?
Yes.
Yes.
Media Connect, which implements RIST, is based on an ECS, which is Amazon's Elastic Container Service, which is a Kubernetes-like environment. So absolutely, yes, no problem at all.
Okay. Next question. In a nutshell, RIST is the better standard. Yes, I agree. Then all the other priorities listed for low latency production workflows. Is that right?
I don't know if I would say production necessarily. I think it's broadcast workflows. Production, it tends to imply, at least to me, intra-only codecs, more like the JPEG XSs of the world. And whilst I think there is something going through the VSF now around JPEG XS over TS, which would then make it applicable for RIST use, that's not where I think the primary use is. It's more in distribution, content delivery workflows, where we're talking potentially long GOP encoding, more distribution codecs. But Tim, sorry, you might have a different view from me on that.
No, that makes sense. I agree. I think it's hard to better. When you say better, it's in what way? So the protocols that kind of group together SRT and RIST and ZXI all have their own technical differences and technical similarities. So there may be certain cases where one or the other will be better. RIST and ZXI tend to be much more similar than the third one. But absolutely, RIST from an interoperability standpoint makes a lot of, so on the technical side, it solves the problem in many different ways. And on the interoperability side, it solves the problem in many different ways. And so for broadcast workflows, it's a great choice.
Okay. I guess that was the last question we had in the deck.
There's a couple in the chat. If you open that,
Yeah,
there's one at least.
I think
yeah,
we
it's
answered it. I think it was the CMake question.
Oh,
the same main
same question.
question.
Yep,
Yes,
okay.
yes. We I know, as I said, for that one, I know it's Ninja. I built it myself. I believe there may be a CMake there somewhere, but I really don't know the answer. I just waffling here. Okay, since there are no more questions, feel free to contact us. Info@RIST-TV is always there, and thank you all for attending.
And then we have a little more notes there. So next week, the RIST Forum will be exhibiting at VidTrans on Monday and Tuesday. And so if you see in the chat window, you'll see a link with more information on VidTrans if you want to participate there.
Yeah, VidTrans is free. VidTrans is the RIST home show, if you will. There will be multiple live demonstrations, remote demonstrations. It's free to attend this year, all virtual, and there will be prizes. And we are open-facedly saying we are bribing you to come. All right.
Okay, thank you, everyone.
Thank
Thank
you.
you. Pleasure. Thanks a lot.
All right. Thank you.